Yeah, Holonym Foundation, just very briefly, we want to make cryptography usable by everybody. And with that comes privacy, security, and ownership. So to accomplish that goal, we have a product called Human Keys. And Human Keys are our way of wrapping up and distributing asymmetric cryptography, public-private key cryptography, to the whole world, where you use our AVS to create human keys, and this can be from any human data. It could be passwords, it could be biometrics. You have Silk, which lets you utilize those human keys in a safe and secure way very easily. And then lastly, you have Zeronym, which lets you prove facts about your identity with your human keys. And this touches many different use cases of cryptography in general, but we believe these are the most important foundational infrastructure pieces, what we're calling the human key infrastructure, that will power all of these incredible use cases that the world will build on top of it.
Hello, my dear ScaleWatchers. Welcome back to the Scale Watching episode. This time we are going to focus about scaling, how to scale privacy. And in fact, we are diving deep into Holonym, a project leveraging the legacy skill of ZK Tech, privacy, in order to create a framework of very interesting privacy-friendly products, such as a wallet, an AVS, and an identity verification tool. So without much further ado, let me welcome the guest for today, Shady from Holonym. Hello, Shady. Welcome to the Scale Watching podcast. How are you?
I'm good. I'm really digging your background there. Are those framed NFTs on the back there, or?
You mean the paintings, right?
Yeah.
They are like in real life paintings. Yeah, they're not NFTs.
Real world assets.
Exactly, absolutely. And yeah, so Shady, I think a great icebreaker would be telling us a bit about yourself and how you came up with the idea of setting up the Holonym ZK powered privacy project.
I would love to. Thanks again for having me on the show. It's definitely an honor, and always down to geek out and chat about how ZK is going to change the world as we know it. Now, this is something I didn't know when I first got started working on this project back in 2022. I had just defending my PhD 2 years prior, and I got really swept up in I really got swept up into Web3, specifically decentralized science. It's something that I was working on in early 2020 and had already sent my PhD advisor. By the time that I was getting close to defend, I said, hey, I don't know if I'm going to do that postdoc. I think I might have to try something a little bit different. And I had in my mind this idea of launching my own research lab in the cloud and calling it DeSci, ripping off the DeFi moniker. Um, and so at that time, it was a crazy idea. It was a really crazy idea. But somehow we made it work. I finished my PhD, started a DAO called OpSci, and that attracted some very interesting people, very deeply interesting, deep thinkers, very interesting problem solvers. And we started building. At first, we were interested in infrastructure for scientific research, how we could make it easier for researchers to reproduce results, to upload data, to prove facts about their research, or in their case, academic reputation. Now, we were lucky to have a really great community and a lot of support from really great foundations within the space, like Filecoin Foundation, like Ethereum Foundation, like other hackathons that were supporting us and helping us out, Ocean Protocol Foundation. And yeah, that allowed us to really get the word out pretty wide. And before we knew it, DeSci was a household name in many parts of Web3, the Web3 bubble. Now, when we really got to building and cutting our teeth on what it means to deploy a distributed application that is uncensorable, that lives on a smart contract blockchain that anybody can utilize at any time, we started really understanding that there are a lot of pros that come with that, but also a ton of cons that you can't really engineer around. And one of those is, hey, if you put your app out there, anybody can use it, which means if you're building a scientific data archival app where anybody can save scientific data for posterity, say like you have a 100 terabyte data set, we had a product called Commons, the Open Science Data Commons, where you could use this portal to upload and pin to IPFS and archive permanently on Filecoin. And our mission was to basically safeguard and store all of the world's scientific knowledge, starting with neuroimaging and brain imaging data. But we had a problem. Well, we were offering people huge upload caps, but no way to actually confirm that the data that they were actually uploading was really scientific data. It could have been anything. So then that's where we started really thinking deeply about identity. My co-founder at the time was starting to really think about different solutions. That's Nanak. And we joined forces with a bunch of other folks at a hackathon at ETH Denver. And we thought, how can we, with privacy, prove facts, off-chain facts about somebody and have them perpetuated on-chain so that dApps can gate and perform logic on the types of services that you offer in a distributed permissionless ecosystem based off of some identity proofs. And then that's where our whole journey began.
Yeah, very impressive background and a lot of interesting tech experiments that you carried out during these past years. And yeah, how would you define Holonym in a few simple words? Like, would it be correct to consider it a framework of products and protocols that leverages ZK proofs in order to solve the privacy-related problems that Web3 has been trying to solve for a very long time?
Absolutely. Yeah, Holonym Foundation, just very briefly, we want to make cryptography usable by everybody. And with that comes privacy, security, and ownership. So to accomplish that goal, we have a product called Human Keys. And Human Keys are our way of wrapping up and distributing asymmetric cryptography, public-private key cryptography, to the whole world, where you use our AVS to create human keys. And this can be from any human data. It could be passwords, it could be biometrics. You have Silk, which lets you utilize those human keys in a safe and secure way very easily. And then lastly, you have Zeronym, which lets you prove facts about your identity with your human keys. And this touches many different use cases of cryptography in general, but we believe these are the most important foundational infrastructure pieces, what we're calling the human key infrastructure, that will power all of these incredible use cases that the world will build on top of it.
Very well. And like, I have a kind of stupid question, but like seeing that I was very active in the Starknet ecosystem during the past 3 years, and they leverage validity proofs, right? So my question is, could you also confirm me that in the case of Holonym, like ZK tech is also used according to its legacy goal, which is privacy, rather than for increasing computational power as it has been for ZK rollups? Or are you also using legacy ZK and validity proofs? What's the difference for light, tech people like me?
Yeah, no, thank you for the great question. Zero knowledge is such a powerful primitive, right? It's really great for, as you pointed out, privacy, being able to prove some fact without revealing the source data, and you can just prove a true false fact. It's also really good at compressing computation. So being able to take a very long series of steps, a very complicated, let's call it the sum protocol, some very difficult operation that will take a very long time to complete, and be able to prove to someone else that you've done that computation at less the time than it would have required initially. And that's a huge unlock, right? If you follow computer science or think about NP hard problems, or if you think about computational complexity quite a bit, these are very desirable traits that you might want to be able to build into a program, especially when it comes to deterministic computation in distributed systems where you're not always quite sure what might happen, right? So we're primarily concerned with the selective revealing abilities of ZK. And we actually make a bit of sacrifices in terms of what someone who's building a ZK rollup might really want to optimize for. So we don't actually use a ZK snark. We don't use a succinct proving system for this because it doesn't really matter for identity. What matters for identity is that you're able to take a very large file that might have many different claims, might have, say, multiple cryptographic signatures from, say, the government to attest that this passport has a valid signature in the chip that's within it. But we don't care so much for making sure that that proof is very, very small so that it can fit on a blockchain, that it's succinct enough to fit on a blockchain. So instead of snarks, we use a different proving system called vol-based ZK, or vol in the head. Vol stands for vectorized oblivious linear evaluation, which is built on oblivious transfer protocols specifically geared towards MPC. And it's interesting because ZK really is a subset of the tools that are available within MPC. And a lot of the stuff that we see today in Web3 centering around ZK and all the narratives that we hear about, it's all about this small subsection that's related to compression and succinctness and blockchain scalability. So vol-based ZK is really powerful. We first heard about it in 2023, was it? Yes, July 2023, a paper came out. We saw that it was possible to generate ZK proofs on top of government IDs with very minimal constraints, meaning very fast computation time, and being able to do it on a consumer device. That's the key. So this is how we get ZK in the hands of consumers, because there really is no point in the person who wants to be private to send their data to a server to then compute something private on. Once it leaves the device, it's not private anymore. And it might be the case where the data might need to leave the server for other use cases. But yeah, I'm happy to talk a little bit more about vol-based ZK and its differences from legacy.
Sure, absolutely. We'll be doing that very, very shortly. And thanks a lot for clarifying my confusion around the matter. And yeah, I think it's now time to dive a bit deeper on the suite of protocols that we are developing at Holonym, which are them and what's their purpose?
Yeah, so all of the protocols we're developing at Holonym are key components of infrastructure for human keys. The first protocol is called Mishti Network. And Mishti Network is an actively validated service on EigenLayer. Basically, it's a threshold network. Yeah, you can actually, yeah, there it is. So it's actually a threshold network that computes a somewhat simple function called the oblivious pseudo-random function. That sounds complicated, but all it means is that you're taking some scalar input from the user and multiplying it by a point on an elliptic curve. And for the savvy audience members, you might see that as a great way to do key derivation, amongst many other important primitives in cryptography. So the oblivious part means that all of the data that the threshold network nodes are receiving are completely blinded. And again, this is using a primitive, the oblivious transfer primitive, to be able to do this so that each node doesn't have any knowledge of the inputs or the outputs. And so with Mishti, each node is incentivized by some tokenomic system where they receive payments for computing a portion of the threshold computation for the OPRF, and then they deliver that computation back to the user, who can then reassemble a key. So why do this obliviously? Well, this means that you can take very low entropy data, like say a universal JWT or JOT, or some, say for example, the output of some biometric scan. It could be a face tech scan, or it could be some other sensor-based scan that's available on consumer devices. You can feed that to the AVS network and securely and privately generate a key on any blockchain or any curve that you need. So this is what we call human keys.
Cool. I have some like technical questions that I prepared about Mishti with the help of my dear friend Nadai, who's the co-host of the Spanish-speaking format that we have, Los Capadoceros. And like entropy is very important for securing many systems, both in Web 2 and Web 3, right? So, however, in blockchain, data like passwords or security questions often result in low security. So how is this area being improved, and how is user data generated, stored, and revealed without compromising security, revealing other data, or making private keys vulnerable?
Great question, and I'm really glad that you asked that. In Web 2, the number one way that we take low entropy user data, say for identity access management, and make it secure enough so that if the server does experience a data breach, that an attacker will still have to exert significant resources to be able to break the password. And that's using a pseudo-random function, where you take, say, I love cats, you put it through the pseudo-random function, which has some parameters, with a known seed, and then you output, say, a 16-bit uniformly distributed set of characters that it's just as hard to guess each of the individual, it just gets progressively harder to guess each of the individual characters. The full solution space is full combinatorial, it's max entropy. Now, in Web 2, the problem is that the pseudo-random function has known parameters. It has a known seed, the input data is known, and also the hash, you could call it, that comes out of it, the password, the randomized password that comes out of it is also known. So while an attacker that just is able to access just the known passwords might have a tough time, an attacker or maybe an internal, say, a collusion might be able to recover the random seed or maybe other properties of the PRF that make it possible to reverse back into the original password. So in Web3, this is even more important because you're typically storing this data, say, either on a blockchain or you're using a public key, right? And you don't want to make it very easy to reverse your public key into your private key by brute forcing the public key. And if you're, say, using like finger scans or face scans, there's a maximum amount of entropy that's available within these biometric scans. And that's for a couple different reasons. The first is there's a ton of redundancy in our faces. We all have eyebrows, we all have eyes, we all have noses. And so that kind of creates a subspace when the total possible number of combinations where an attacker can focus their computational power. That's one side of it. The second is a lot of the facial recognition tech relies on some sort of downsampling where you take this very rich input feature set and you reduce it into something even smaller, which further decreases the full possible combinatorial set size, making it even easier for an attacker to make his way through. So we solved this with Mishti network by using an oblivious pseudo-random function where none of the nodes know anything about the seed, they don't know anything about the inputs or the outputs. And we also do this in a way where we can take any input data and make sure that the output is always set at a certain entropy limit. I think for Mishti vanilla version, what's available today, I believe it's 128 bits, which matches most RSA key security.
Very, very interesting. And also like the Mishti network of nodes also manages and stores private keys, which can also be very useful for certain use cases. And it is also integrated on EigenLayer, as far as I remember. How do these nodes operate? How is the information distributed in order to maintain a good level of decentralization among the nodes? And how is its access managed while while preserving privacy and security. Then also like what happens if a wallet if a user loses the private keys of the wallet, are there ways to recover the account and stuff like that?
Yeah, good questions. I hope I can add a little bit of clarity here. These are all really great questions, and I'll try my best to answer them all. The one thing to note is Mishti Network. So here's a key thing, no pun intended with human keys. If you can present yourself at any point and derive a key from yourself, from your humanity, then you don't need to store your key anywhere because the key is you. With Mishti, what you do, it doesn't actually store the keys. You present it with the data, you use the oblivious pseudorandom function, and each individual node is incentivized to perform the correct computation. And they're checked. They're checked using discrete log quality proof, another form of ZK that's embedded within the network to make sure that the nodes are able to remain private without colluding with each other. And you return to the user the results of the computation. But those results of the computation aren't stored in Mishti. The user has to then run some client-side code or some UI, that's what Silk does, and reconstruct the key into something usable. As for the nodes, we have a pretty high bar for which nodes can run Mishti network code. So as an AVS, we're focused primarily with operators that have a lot to lose by doing something, by mismanaging keys or not being able to serve users their keys. So these would be operators such as consensus, P2P, Renzo, to name just a few. And these node operators are incentivized to continue participating in the network because it is lucrative every time an individual creates a key, such as to sign in or to authenticate or to recover their key. They're going to be receiving a little micropayment from that. And they're also going to be incentivized to maintain their staked ether as security for the actual network. In the case that if they want to continue earning, they have to put this ether up at stake. Just to be clear, we don't slash stakers because there aren't really any slashable mechanism, like any slashable offenses really that they can commit. Just that their ability to be elected into the participating nodes for each iteration whenever a user queries the network will be weighted based off of their basically how well of an operator they really are. So there's a lot happening under the hood with Mishti, but in the end, it's really simple. Mishti is a distributed computation service that lets folks derive keys client side by presenting some low entropy data that's memorable or easy to keep around.
Very well understood. And I think now we could also speak about the most successful product of Holonym so far, so Zeronym. I don't know if you would like to introduce it, and then we'll dive a bit deeper into it.
Absolutely, yeah. I would love to talk about Zeronym. So, as I was saying, when we first got started, we were building tools for scientists to be able to prove their identity. And actually, we launched Zeronym. Back then, it was just known as Holonym. That's what we were. We launched that on actually April 20th at ETH Amsterdam, on 420 ETH Amsterdam. We came out and we showed how you could take some private proof off-chain and on your identity, and then prove that on-chain with privacy. And we created a big, nice decentralized registry of scientific identities where people were starting to prove that they had different scientific credentials. And people got pretty excited about it. A couple of devs actually reached out shortly afterwards. They were building a DAO, basically some governance infrastructure for a political DAO that was started by Andrew Yang, who was a US presidential candidate, I think in 2020, also perhaps in 2016 he might have ran. And he wanted to basically use the power of distributed fundraising, crowdfunding through crypto to power campaigns and support campaigns he really cared about, like anti-poverty, UBI, those sorts of things. The problem is that as a lobbying organization, they could only deploy funds from verified US residents. So only those that actually lived in the US could actually donate to campaigns. Otherwise, they'd be out of compliance with the law and would be at risk of getting shut down. So they saw what we were building and they immediately connected the dots. And we helped them out really quick, kind of salvaged the whole situation by providing them with the first zero knowledge KYC with an on-chain attestation that a user has passed some verification flow and that they have a proof of residence within the, or proof of US, yeah, basically proof of US residence. And that way we were doing it with driver's licenses and passports. So yeah, so that was really helpful, I think, to really get to help us as a team understand that this product had traction and real world usability, both in Web3 and possibly outside of Web3. And a year after that, a year and a half after that, we came out of beta and launched with Gitcoin Passport at the time. And since then, we've had about almost 150,000 users completing almost 200,000 CKPs, which we're really excited about. Can tell you about all of the crazy shenanigans of what it takes to scale a ZK protocol. In the beginning, we were actually using snarks. We were using succinct proving systems, and we were doing everything with an on-chain Merkle tree. But once we hit 30,000 users, it became very computationally taxing for users to download the Merkle tree from on-chain and then reconstruct the entire tree so that they can compute their node and add themselves to the tree, recompress the tree, and then put it back on the server. When we first shipped it, it was something like a minute and a half. By the time that our 30,000th user was trying to verify, it was taking like upwards like 20 minutes on a Mac, an hour and a half on like a Lenovo or like a PC. So that was unacceptable. We refused to accept that this was the limitation of what ZK could do. And that's when we moved to a non-succinct proving system, the role-based ZK, which lets us sacrifice succinctness. It also lets us we don't have to put our proofs on chain anymore. But now we can compute things very, very, very fast. And now anyone, anywhere in the world can produce ZK proofs on their phone.
Very well, Shady. And like Zeronym helps maintain privacy while proving either our data or certain facts about ourselves using ZK proofs and a special way of registering your identity with a soulbound token, with an SBT. So what is the process for generating these SBT? What methods are currently active? What can we achieve with it?
Yeah, happy to answer the question. With Zeronym, there's a few ways that you can verify, and they can be used for different purposes. The number one purpose currently is Sybil resistance for security against bots, bot farm attacks, protecting quadratic funding for decentralized grants, one person, one vote mechanisms, for example, with Vakdoni, etc. So to prove your unique humanity, we do this with a proof of legal personhood, and there's two ways to do this. One is if you have a standard ID, like a driver's license or a national ID card, we actually wrap an existing identity verification provider, get the signature for them that this is a valid credential, and then basically throw your ID into an identity mixer, a tornado cache for credentials. And this breaks the link between the identity verifier and the actual data that you're trying to keep secure. The second way is more privacy preserving because it doesn't require a third party, where all you need is a credential with an NFC chip in it that follows the ICAO 9303 standard. This means that this credential has a collaboration of different governments and state departments across the world that have public key infrastructure. Believe it or not, governments actually using PKI to manage their signing certificate authorities, to manage who has which keys, who can sign with which keys, how often they're rotated. And this is actually a very robust and resilient way for managing government ID. It's also permissionless, believe it or not, because once you have a credential from the government, you can use that signature from the government to produce any sort of proof on your data. And you don't need to talk to anyone else to do that. You can just let the credential speak for itself. So we offer this credential service. It's super fast. It's totally free. We subsidize everything for the user. And they just need to tap their phone to the NFC antenna or tap their credential to the NFC antenna on the phone. And then they're able to generate the proof in under a minute on their mobile device. And then they can receive an attestation on chain.
Oh, that's very interesting. So you kind of also leverage this kind of tech adopted by the governments, which is the kind of tech that, for example, you use in order to identify yourself, in order to to enter, for example, the tax authority, stuff like that. There's a different name for each language, but I understood what you meant. And also, like, Zeronym is also designed to resist the Sybil attacks. It can also airdrop, like Sybil resistant airdrop is one of the problems that you want to solve. You also wrote a very interesting article about that I will add in the description box. And you also want to prove actions performed with different accounts, but also, like, for example, by the same person over time, like a voter using a different account each year. And how does the action ID work in such cases?
Yeah, so developers that are integrating Holonym can use the default action ID, which just proves that this user has verified, is a unique user, and they verified with Holonym and they're accessing the service. But developers can allow for their services to be consumable and rate limited how many times a user can consume a particular type of service based off of the proof they carry. So for example, you can have action IDs that differentiate between, say, residents in low income countries to claim faucet, say gas tokens from a faucet versus, say, those from a higher SES status. Say they might have like a higher limit on a UBI or some faucet or something like that. The action ID also comes in handy when we're thinking about more complex uses of the zkKYC outside of Sybil resistance. We recently just announced a new feature set within Zeronym that was made possible by Mishti Network that allows you to not only prove the legal personhood of an individual, but also to prove that they're not on an AML list. We call this proof of clean hands, and we think it'll be incredibly instrumental for any real world assets built on top of Ethereum. We think it'll be really important for any sort of technology that's going to interface with the real world, whether it's grants, whether it's nonprofits, whether it's on-chain assets, etc. The way proof of clean hands works is basically when the user goes through an onboarding flow for a new project or, say, a permission DeFi pool, they're prompted with a pop-up. And the pop-up is basically an agreement. The agreement asks the user, do you consent to use this protocol with privacy? And do you agree that your data will only be decrypted or made available if you break the following conditions? These conditions could be interacting with a blacklisted address. It could be showing up on a sanctions list. It could also be that your address gets audited by FinCEN or by the US government. And each dApp can mold this to fit the requirements, the legal requirements of the jurisdiction that they operate in. So what we're doing here is that the user is private by default. We're allowing different jurisdictions to adapt what sort of legal requirements they'll have to instantiate on chain with the ability to do so that they can remain in business. And then the user gets this optionality to consent into agreements to use services that best fit their privacy needs. And so once the user agrees, right, they go through the zkKYC flow as normal. But what's happening on the back end is that they'll sign a transaction that encrypts their data to a decentralized network. And the key, the public key to be able to decrypt that data, say it's the key that's attached to the compliance officer or to some regulator at that country that's regulating these sorts of businesses, that key is gated within Mishti Network. Mishti network lets them derive this key, but the key can only be released from Mishti network if all of the conditions that the user agreed to are verified within a smart contract. So what do you have here? You have basically transparent accountability. You put the onus on the user to say, hey, your privacy is a privilege. As you use this application and you follow the social contract of the application, your privacy is always guaranteed. However, if you come into contradiction with any of these requirements that are on-chain, that are transparent for everyone to see, then an external third party will be able to decrypt your data. But that third party can only decrypt that data if those conditions are met, which means no more mass surveillance. And every time that that third party does decrypt that data, it's visible for everybody to see, which means that you have less ability for unsolicited mass surveillance. It's very clear what those that are requesting information can do. So while we think this is a really great niche use case for DeFi and dark pools and privacy chains, we're really excited to ship this out for Aztec coming up soon, where if you want to bridge your funds from Ethereum to Aztec for privacy, but also need to, you also want to be able to show compliance for the jurisdiction that you're in because of the business that you're doing, that'll become possible. But we think this is also a really powerful primitive in general about how accountability and transparency should work in some of these distributed crypto governance mechanisms and ecosystems.
Those are very useful tools that I think they are very much needed in the space in order also to reach the so-called mass adoption. And I was also a bit laughing inside myself because I actually performed an AML check today with my bank. And so I was thinking we definitely need this kind of tools also in order to improve the reputation of this industry, because sometimes it's really frustrating because they make you feel as if you're a bad actor, right? And you grow this kind of anxiety. And I think that tools like Clean Hands are gonna improve this the reputation of Web3 and of the people that work in the Web3 business. And because also we also understand also from the perspective of banks, because they need to be super compliant. So they also need a kind of tool that gives them some reassurances. So I think that these are definitely tools that will be game changers in DeFi, and they will help us reach that kind of adoption that we are struggle to reach at the moment. And also Zeronym integrates Velo, as you were saying, which is a set of powerful mathematical algorithms based on circuits like Circom. This allows users with SBT, with the Southbound token, and Zeronym's proofs to also create proofs of humanity. And my question is, can this information be used across all ZK EVM compatible chains, for example, Aztec, Scroll, ZK Sync, or are there any limitations to be aware of?
Absolutely. Yes, great question. The SBTs can be used across any EVM. The main consideration there is we want to make sure that the address is mappable, that you can map the address across EVMs, because if you have the SBT on one chain, you can prove that that mappable account also has that SBT. Currently, all of the SBT attestations are being minted on Optimism. That's just where we got started. However, they're being broadcast across different ecosystems through integrations with attestation service providers like Sign Protocol, for example, like Verax as well for Linnea. And through Gitcoin Passport, we're also pushing these to EAS. And it's interesting because if we look at attestations, they've been around for a while and they've been talked about all sorts of things. The primary use case has been identity, and we see that as well in the total volume of attestations. But yes, to answer your question, it's something that you can use across EVM chains very easily.
Very well. And I think we could also spend some words about the wallet solution that you're implementing in this set of tools, which is, let me share it, which is the Silk wallet. So could you tell us a bit more about it?
Yeah, happy to. So just rewinding, human keys are how we think about usable security by bringing cryptography to a wide audience. And we want to start in Web3, where power users, where those that are really devoted to the industry can help us prove these ideas and concepts out. So, like we covered already, Mishti Network lets you create human keys, and then Silk lets you use the human keys. Silk is an embeddable iframe wallet, so you can think of it as a universal account that can appear anywhere on web, on mobile. It can appear in any browser. It doesn't require any apps or downloads or extensions or anything like that, but it lets you access your keys and interact with different backends, say like different blockchains, different decentralized networks. Um, and the way that it does this is Silk uses Mishti to actually create very simple onboarding experiences for users. This is geared primarily for developers, where you can, with just a couple clicks, have with just a couple clicks, you can have a user create a wallet just from a social account. And once they're in, they're able to further secure the account by adding a password that can be used to derive their key a little more securely. So that way, it's not the social account that's able to recover the wallet, but only the person who has the password or perhaps the biometrics. Silk has a lot of really great features under the hood. One of them is a social payment link. So you can pay anybody by sending them a link that they can claim. And it's very simple if you do this, like for example, with your grandma, you can send her $10 in USDC to thank her for lunch, and you can text it to her. She'll hit the link and be able to open up a social claim page where she logs in and is able to claim the funds. There's also a gas tank implementation where you can, as you're onboarding, you can fill up, pay an onboarding fee, basically a gas tank fill up, and then that gas tank will pay for your gas across chains. So you don't need to keep tokens on different chains to be able to execute transactions. There's a couple of other, nifty features that are hiding in plain sight there in Silk. And we're really excited to launch a points program for developers to begin kind of experimenting and seeing what problems we're really able to knock out of the park.
Yeah, absolutely. I also I played a bit with the wallet, and I deposited some money. So obviously you can notice that you're working on it, and yeah, really looking forward to seeing the different use cases that you and also the new developers that are going to play this framework are going to produce in the coming future. And so let's also finish this episode where I learned a lot of things, and I'm very grateful for that. I really enjoyed it, but I also I wanted to give also some credit to your team, to Holonym, because even though we are talking about a very technical project, you're also working very hard in order to establish an active community of both users and dev contributors. So just what are the community initiatives that you've been working on? Maybe we can also mention the recent seed round that you carried out.
Yeah, I'd love to. Yeah, thanks for for the call out there. We just closed our seed round. We just raised 5.5 million US dollars, led by Finality, who's an active investor in the AVS and EigenLayer space. Co-led with Paper, and Paper Ventures are just a great group with crypto OGs that have been in the space and working in different capacities behind the scenes for the past 10 years almost. Yeah, we're super stoked to be able to close this raise and put a lot of this funding back into the development of the project and growing the existing programs and campaigns that we have for the community. So if you guys are listening, go over to our website, look for our Discord link in our footer under our ecosystem. Join the Discord because every week, every Sunday, we have a ZK Holonym trivia night where you'll be quizzed on all sorts of things like what is bull in the head, how does silk work, what are human keys, and all sorts of stuff. And you can win up to $100 cash prize. And I think up to 3 winners are selected every week based off of the points. So we're growing a pretty active community of nerds and dweebs that like talking about this stuff all the time. So definitely pop in. In the very near future, we'll be launching a points program for developers. And that I think will definitely knock on to some incentives for users in the near future.
Very, very promising. And yeah, I must also disclaim that I also participated in this round as an LP for WAGMI Ventures, a venture that also participated in the round. And also I take advantage of this to say that the content of this scale watching episode was not financial advice, but as you can notice, was very like a technical and educational piece of content that we hope you enjoyed. I would love to thank Shady for his time, and I would love to wish him and his team all the best, and hopefully to have you back at the scale watching podcast.
Oh, thanks for having me on board. It's been a very delightful conversation. I can't believe it's been 45 minutes. It feels like we just started talking.
Exactly. Yeah. So that means that it went through pretty well, and we enjoyed it, which is the most important thing. And yeah, once again, thanks a lot, Shady, and thanks a lot to all the viewers. You will find all the links, also the Discord link, in order to get some chance to win some nerdy quiz. And yeah, so once again, thanks a lot, Shady, and see you the next time. Take care.
Okay. Catch you around, guys. Thank you so much. Bye-bye.